Okay, next is a new subtopic 5.2, Induced EMF. Okay, explain the induced EMF by using Faraday's experiment, state and use Faraday's law, and state and use Lenz's law to determine the direction of induced current. Okay, so first thing first, sebelum kita explain induced EMF by using Faraday's experiment, you have to know what is the Faraday's law. Inside this subtopic induced EMF, we consider have two laws. First is Faraday's law and second one is Lenz's law. Okay, Faraday's law state that the magnitude of the induced EMF is proportional to the rate of change of magnetic flux. Okay, so by mathematics we can write as induced EMF is directly proportional with d flux per dt, negative d flux per dt. So d flux is change of magnetic flux, dt is change of time, and EMF is induced EMF. Epsilon is induced EMF. For n turns, so you just add up with the number of turns here. Okay, sama je. Dan syarat dia untuk we have the induced EMF, dia mesti terhasil kalau ada change of flux. Okay, kalau tak ada perubahan flux, dia tak boleh berlaku induce. Okay, no induced EMF will occur. Okay, where flux here is flux final and flux initial is initial magnetic flux. Okay, as you know that induced EMF is equal to negative n d flux per dt. So here flux yang you belajar sebelum ni, magnetic flux, is BA cos theta. Meaning that to produce the induced EMF, you mesti ada changing either one of these three types. Sama ada B changing, A and cos theta is constant, A changing, or B and cos theta is constant, or rotation. Maksudnya angle changing but B and A is constant. Okay, so maksudnya mesti ada perubahan salah satu daripada tiga benda ni baru boleh jadi induced EMF. No changing, no induced. Okay, so negative sign here is indicate that the direction of induced EMF always oppose the change of magnetic flux producing it. So nanti you akan tengoklah apa yang kita akan oppose change of magnetic flux tersebut, itu adalah Lenz's law. So perlu tak untuk calculation masukkan negatif? Yes, perlu. Okay, kecuali dalam soalan dia minta magnitude. Dia direct said that calculate the magnitude of induced EMF. So itu kalau kita letak negatif pun betul, letak negatif pun betul. Tak consider pun betul, consider pun betul. Tapi kalau dia sebut induced EMF, we must consider that induced EMF ada negative sign dekat sini. So better gunalah, better guna. Alright, so induced EMF produce induced current. Okay, sebab you ada induced EMF, you mesti ada induced current. Dan di situ juga bila induced EMF berlaku, dia mesti ada temporary magnetic field. Kita panggil B induced lah. Magnetic field induced. Magnetic field strength induced mesti akan wujud E induced, and then ada current induced. Okay, ni macam Ohm's law lah. V is equal to IR. Cuma awak gantikan dia V ni dalam keadaan induced EMF. Temporary current, temporary voltage. Okay, bukan permanent lah. Alright, so next ni notes. Okay, ni yang saya cakap tadi. To produce the induced EMF, we must consider that we have three cases here. Untuk case yang melibatkan satu-satu benda lah. Okay, alright, so first case, if let's say we have change of B, perubahan B, so ini yang kita akan guna. Kalau case kedua, changing of area, so ni kita akan guna. Kalau changing of rotation, so this equation yang kita akan guna to produce the induced EMF. Okay, you just susun formula you and then tengok apa yang berubah dalam soalan. Kalau yang berubah dalam soalan tu letak kat belakang. Okay, yang lain semua pergi depan. Alright, so next kita tengok how to use Faraday's law. Okay, first case, let's say dia kata changing in magnetic field. Dia tak cakap dalam soalan, mungkin dia bagi tahulah. Okay, change from apa to apa. A coil with 25 turns of wire is wrapped on the frame with a square cross-sectional area of 1.8 cm on the side. Each turn has the same area equal of the frame, and apply uniform magnetic field is perpendicular to the plane of the coil. Ayat ni kena faham. Uniform magnetic field is perpendicular to the plane of the coil. Plane of the coil is perpendicular to the B. Is it? Okay. So the angle is 0 because vector area A and B is 0. Vector area A always 90 degree to the surface. Okay, next dia kata if the field change from 0 to 0.5 Tesla in 0.8 second. So apa yang berubah kat sini? B changing. So use formula of induced EMF is equal to NA cos theta dB per dt. So means that changing of magnetic field. Okay, substitute the value. Okay, this area is one side. Jadi kalau nak dapatkan area yang petak, you kena kali 2 lah. Surface area. Okay, so B final minus B initial. Final is 0.5 Tesla minus 0 divide by 0.8 second. So you will get induced EMF equal to negative 5.06 times 10 to the power of negative 3 volt. Why negative here? When the magnetic field is increased, the change in magnetic field is positive. Here is positive. So, induced EMF is negative because to oppose the increasing in magnetic field. Sebab tu dia negatif. Sebab dia nak menentang kenaikan magnetic field. Syarat dia penentangan je, okay? Nak menentang apa? Menentang, ikutlah. Kalau dia kata magnetic field, is magnetic field. Kalau increasing in area, area lah. Okay? Dia tak sukakan perubahan. I mean, you buat perubahan, dia kena oppose the change that producing it. Macam tu lah. Okay. So next, second case. Second case is, let's say the changing in area. So we have a loop with 10 turns and radius of 0.4 meter is placed perpendicularly in uniform magnetic field 0.5 Tesla. Okay, calculate the induced EMF when the point A and C was pulled over until the area of the loop is decreased to 0 in 5 seconds. Means they pull out here. Pull out until dia punya shape jadi macam ni. Okay, alright. So kita nak kira maksudnya from this area become this area. Okay, so first you kena carilah dia punya area dulu because they give you radius, so pi r square, and then we get area is 0.503 meter square. Okay, substitute in formula of induced EMF with changing area. Okay, A final minus A initial. Okay, final is reduced to 0 kan? 0 minus 0.503 divided by time is duration is 5 seconds. So we get 0.503 volt. Okay, when area decrease from where? From 0.503 to 0. Okay, the change in area is negative. Maksudnya bila kita kira kat sini, kita dapat negative value. Okay, so induced EMF is positive. Okay, kenapa dia positif? Sebab dia nak oppose pengurangan dalam area. Sebab tu nilai dia positif. Okay, saya harap buat clear lah. Okay, case yang ketiga, changing in rotation. Maksudnya dia berpusing. Okay, we have a singular loop with radius of 0.8 meter is placed perpendicularly in magnetic field of 0.7 Tesla. Calculate the induced EMF when the coil is rotate clockwise about 90 degree in 5 seconds. So maksudnya you kena pandai imagine benda ni. So kalau initially saya nampak ini surface and then B ni teracak keluar maksud saya into the page. So daripada pandangan tepi, kalau saya pandang mata macam ni, saya nampak lah macam ni contoh. Okay, kita nampak tepi coil and then kita nampak B dia tu keluar. Ini waktu initially like this. Okay, so waktu ni angle antara B dengan A tu, kalau you boleh cucuk pencil you tu dekat screen. Okay, cucuk B tu into page and then surface area adalah vector area A adalah perpendicular from this surface. So dua-dua tercucuk dekat you punya screen kan. And then maksudnya B dengan A tu adalah parallel. So angle-nya adalah kosong. Okay, so bila dia rotate maksudnya you pusing, jadi kedudukan dia akan nampak macam ni. Bila dia pusing, you akan nampak side tepi je daripada pandangan atas ni. So bila dia rotate 90 degree, ni benda ni nak rotate 90 degree, 90 degree. So dia akan jadi shape macam ni. So waktu ini vector area A dengan B dah jadi 90 degree. Okay, so waktu ni theta final you dah 90 degree. Okay, masuk dalam formula induced EMF with changing of rotation. So cos final minus cos initial, so bahagi dengan 5. So kita akan dapatlah 0.281 volt. Okay, alright.